Hi, welcome to my session on logic apps in manufacturing. So I'm Stefan Wiggers, and I'm going to talk about a customer case that I worked on in manufacturing. Like I said, a customer case, setup, technology, monitoring, support, lessons learned. So I'm kind of going to dive into these topics. So that's kind of the agenda for this talk. And yeah, it's about a customer case in manufacturing. So it involves Dynamics 365 as an ERP system that communicates with other systems, including machines that run on-prem that receive production orders that need to be, do its production basically. And it will give you some information back. At least the machines will give the information back, like report is finished. That needs to be entered back into Dynamics. So the complete setup of this particular customer, similar to other customers that I've worked at, two customers actually that did ERP and manufacturing, that kind of stuff. So you got your Dynamics Finance and Supply Chain Management that talks to several systems, including production systems. And these production systems also report back some of the information of running their production, running or creating a product, basically. There's some other systems listed here as well. Something about Recipe Studio, advanced shipping notice. So that's kind of an intercompany exchange of information, and also sales orders. But yeah, in general, I'll just talk about Dynamics communicating with these systems, and you see some of these systems communicating back to Dynamics. So you're dealing with outbound integrations and you're dealing with inbound integrations, if you look at that. The approach was basically decoupling, as in there's information coming out of Dynamics and then going to these other systems, and these other systems might report back, and those messages or payloads basically get transformed back into and sent to Dynamics. So Outbound was more or less based on business events and the concept of business events. Something changed within Dynamics. For instance, a production order confirmed, meaning that the production order can actually happen on the system that runs somewhere in a factory on-premise. So it's an on-prem integration, basically. We used Logic App for the in and outbound interfaces. So the controlling the process of an outbound, or let's say an outbound message, which could be a production order that needs to be sent to the production system. And on the other end, it could also be that the production system reports back that it's finished with some of the goods it used to produce something, and that's put back as a transactional message in Dynamics as being a journal. For this, we use Logic App to do that orchestration. However, the mapping of in and outbound payloads were done by functions. And it was all asynchronous communication based on a certain workload. There were X amount of production orders, I think about up to 50 or 60, and also report banks. So the payloads and the workloads are pretty low in that perspective. And handleable, and were able to be handled by Dynamics easily. So the technology choices were using Logic App consumption. Although Logic App Standard was available in preview, ultimately we didn't go for the Logic App Standard, also because there was no actual requirement for some of the capabilities that it support, like VNet integration. We're using Azure Functions, so the consumption model for that one as well, for the mapping and formatting of and the parsing of from JSON to XML or to text files. And I'll talk about that as well. We're using some simple managed connections for our Logic App. So there's interaction with Service Bus, Key Vault, File, Office for email. I'll talk about that. And the secure FTP connector that was available as well. And then with the file adapter, we also combined that with integration with the on-premise data gateway for the on-premise connectivity. So the production orders were moved towards the on-premise system, as in the on-premise network. From the network, those messages were pushed towards those machines. So those machines were not connected to the internet. It will ingest that data, ingest those messages, actually those orders, produce, and then report back eventually also through the on-premise networking. Again, the on-premise data gateway plays a role in getting the message up to Azure, where it's then subsequently transactionally processed by sending commands towards, or at least transactional messages, to Dynamics 365. For deployment, we were using ARM templates back in the day, so we were not, Bicep was not available yet, so we're using ARM. And for notifications of errors, that was through email. So the landscape kind of looked like what you're seeing now. So it's, You got a dev test subscription, you got a production subscription. Within the subscription, there were a couple of resource groups, and within those resource groups, as you can see, there was like a more generic one, common one, where you could find a common event grid topic, service bus namespace, and storage account. We had a resource group for some monitoring capabilities, like Logic App of the Logic and Log Analytics workspace, combined with an OMS dashboard. We had a separate resource group with all the Logic App that was kind of required for the orchestration of in and outbound interfaces, as I said before. And we have the functions doing the mapping and also moving from one format to the other one. Environment-wise, we had a development, test, acceptance, and production, and each of these environments was tied to an instance of Dynamics. Then the deployment was done through ARM templates, so we were using Azure DevOps for it, so the repo, the boards, but also the pipelines, and also using some of the wiki capabilities within Azure DevOps as well, all tied to a tenant. Azure Active Directory also tied to a team where you can find some other information, or at least the documents that were like referenced within the Azure in the DevOps wiki were documents as more functional documentation within SharePoint through Teams. So it's kind of the overall setup or landscape for this particular use case. So let's more dive into the integration itself. So on one end, you have your outbound integration, which means that a business event occurs within Dynamics. This business event gets kind of enqueued, but then ultimately needs to be delivered to actually an event grid topic. To do that, you need to configure an endpoint, which I will discuss later on. That particular event gets parsed, then based on that business event, it just contains a small amount of data, let's say a production order, ID, and some other information, allows us to call back to Dynamics through a trust between Azure and the Microsoft Cloud. That's where Dynamics is hosted, to retrieve that data. That's kind of an enriched message that's being placed on a service bus topic with certain properties. And then you have listeners. One of the listeners picks up that particular message, enrich it further through mapping, or at least the enriched message goes through mapping. And then ultimately, if it needs to be another format, another function will convert that, for instance, as depicted here, in a text file, which is subsequently sent to a file share on-prem. So that's where the on-premise data gateway comes in and the file connector for the Logic app. On the flip side, so the inbound integration, particularly for the production orders, that goes to the on-prem network, as I explained earlier, and from the on-prem network back to Azure, is that the inbound also uses the on-premise data gateway and the file adapter. That's a text file. The text file gets processed basically into a JSON message, JSON payload that's being pushed towards a queue, which subsequently picks it up and then starts interacting with Dynamics by creating a journal header, journal items, and a data action to confirm or basically set the transaction for the journal itself. As you can see in the previous slide, and also this one, that each of the Logic apps also have kind of a tagging, what type of Logic app it is, and I will dive that in when we come to monitoring. So the concept of outbound is through the business events. So business events are available in Dynamics as is. There are just standard amount of business events available, but you can also create a custom business event if you want. That business event ultimately needs to be delivered to what's called an endpoint, and the endpoint configuration is something that you can do in Dynamics, as you see in this slide. An endpoint can be towards a event grid topic, but it can also be a service bus or some of the other options available within Dynamics, as in configuring an endpoint to deliver that particular business event information. So in this case, you need an app registration that allows you to have that trust between Dynamics and the cloud, and it's also necessary to retrieve information from a key vault, where the information is regarding your event grid topic, more or less the DNS, more or less the secret or signature key, I believe, what you need, and that you can find that there in the key vault. So ultimately, that will look something like this. So you have an endpoint URL, your app registration information, your key vault DNS name, what the name of your secret is, at least the key, and then the value has to be retrieved. If you click OK, it will render and set up this connection. If it fails, then you get an error message. So ultimately how this flow is, and this is just an overall view of that flow, is that through Dynamics 365, a business event, let's say production order, let's say it's confirmed, ends up at an event grid topic. From that event grid topic, you have a listener, which is one of the Logic apps. That Logic app subsequently will call out to Dynamics using another app registration, retrieving more of that information, Then it would enrich that message and send it towards a service bus namespace. Then there would be another logic app listening to it because it has a different type of responsibility. One logic app is responsible of getting the information. The other one's responsible of parsing, mapping it, and ultimately deliver it, let's say, to an Azure file share or an on-prem, or through an on-premise data gateway, that file adapter, to on-prem, where subsequently it's been transported towards the machines. How does particularly this business event look like? This is depicted here. It looks like this is a sales order confirmed business event. It has some information that you can parse within a logic app, and then you can leverage to call out to Dynamics to retrieve more information. And these call outs we did using the OData protocol. And if you're familiar with the OData protocol, it's kind of a protocol where you can query on top of entities within Dynamics, for instance, and then you get information back. And you can apply certain filters on top of it, allowing you to get the subset of data that you want out of an entity. So that's kind of what your open data protocol is, and that's supported in Dynamics. It starts with a resource URI, resource path, and then your query options, as you can see. And you can also apply some of the filter operations, as you can see, like equal, greater than, logical, something you find in logic apps as well if you're using a condition action. So no data call from we leverage an HTTP connector, so not the connectors available Dynamics, where we're using the HTTP connector because it gives us better performance, and we just want to standardize and just using as least connectors as possible in this case. As you can see there, filter expression is right there where I have the box, the filter expression, then the URL, and subsequently what type of query I want to do, which type of entity, including also the security through tenant ID, URL, client ID, and secret. And the secret comes from the key vault again. So that's why that connector is there. What's really important, having those logic app orchestrate the in and outbound communication with those systems, is that it's robust, that it has kind of error handling. So what we did is that all of the logic app have, that tag with IE, XT, and then a number that's required to identify what logic app potentially has a failure. So if it fails, then the information is sent towards an error message queue where there's a logic app listening to it, and then forms kind of a message, an error message that's being sent out as an explanation, as you can see here, or at least an example of that something went wrong in a certain environment. And we did this because it's very important to have kind of the identification where in your process or where in your logic app something fails, so you can act upon it. And for this, I just have prepared a very small demo, what I call a robust HTTP logic app that kind of follows the same paradigm with try, catch, and finally. So if I switch over, then you can see my logic app, the robust logic app. Let me just click to the designer view so you have a kind of a sense how this looks. This was just in general applied for all the logic apps. So you have, in this case, it's HTTP win, and then you have a try, catch, and finally. And in the try, you just have one, well, you can have multiple actions. This is just my, I'm just calling an API, and that API result gives a result back. And if somehow that fails, then I have a catch block with a couple of actions to basically get the error message out of one of the actions in the try activity. And then I have an error. Potentially, I can have also send this to a queue. It's not in this one, but I could do that. And then I have a finally that I can do response back and terminate. So if I would execute this using, for instance, Postman. So I'm calling out to the logic app. Let's just do number one. I will send this out, and it will give me a result back. It just calls back to a Star Wars API, and then the number one is Luke Skywalker. Of course, if I do 100, then this will fail because there are not 100 people in the database of Star Wars. So now it fails. So that's responded back. If I switch to my logic app and I just expect these runs. So in particular, I'm just going to look at this one. This one failed, as you can see. It fails here. because detail not found. That, of course, ends up in the catch block, where you just respond back to the caller in this case. But then you start with the filter array because you want to get that information of the action that failed. So if I just scroll down a little bit more, then you can see that status 404. And some of that information is that consolidated, and you can send this, in the case of the customer, towards a queue, and then subsequently Logic App gives that information back to an incident management system, or at least sends it out to people saying, hey, this failed. So this is kind of a demo, but it's very, very important because all these Logic Apps were instrumented that way. So allowing us to identify where in our processes something failed and then notify someone so they can act upon it. So the mean time of identifier is pretty much reduced a lot with just implementing zero error handling. But I think in general, you should make your Logic Apps robust using this type of manner of implementing a try, catch, and finally. Now, if I want to continue, so I talked about in and outbound, something that's very important, error handling in general, also when you do coding in within the function, that contains error handling as well. I want to dive a little bit more into the experience and challenges, lessons learned regarding this particular use case. So one of the things that is pretty important as well is having automate as much as possible. So having each environment set up correctly. Initially, you could do this with landing zone, but going forward, when you push some of your common resources out, you can use infrastructure as code and have this correctly set up in all the environments to prevent configuration drift. The other thing is you set up monitoring as well, equally configured as well in all these environments, similar to all your interfaces and the Logic Apps and your functions using ARM templates and everything. For the Logic App, you kind of have to extract it. So the experience from a developer perspective is that for the consumption Logic App, Portal is fantastic. So you build your Logic Apps there, you can test them in the Portal. Means well, what I just showed you through a Postman, but differently you do a production order confirmed within an instance of Dynamics in a test environment, and will produce that business event, and then you can follow through in the Logic App going all the way down to on-premise if it's delivered. If you all tested it all and you think, okay, this works, then you can use that Logic App template extractor built by Jeff Holland initially, and Matthias Lockbeck continue maintaining this. Allows you to extract that template, optimizes it in using Visual Studio or Visual Code, and then push that to an Azure repo where you subsequently deploy that using Azure pipeline. So within your solution on-prem with the template of your Logic App, that's basically your workflow definition, but also some of the parameters for different environments. And the ARM template itself, you can push that to the repo, and then you can push that towards other environments. Similarly, functions you can build and test in Visual Studio, but then you can do this locally. You test it potentially by using Postman. You push that to the repo as well and use and deploy those through Azure pipelines as well. And within that, you can also apply certain branch strategy and extra going forward. The other aspect is monitoring. So the monitoring of your complete setup. So end-to-end monitoring. So how are you going to do this? So some of the monitoring we implemented using a workbook. Another thing is we're using Log Analytics Workspace. So you see a little screenshot there as well of all the Logic Apps. We're also using Application Insight, of course, for our functions. And we potentially also early on looked at Serverless 360 as a means to do this monitoring. That's not something you can buy off the shelf and configure and allow that to have that as a monitoring setup for, in this case, the Logic Apps. We ultimately ended up by using some of the things like what Azure natively provides and not went for a off-the-shelf product, but had more to do with the fact how monitoring was set up and who took ownership, but I'll dive into that later. Well, actually now, some of the challenges are like how we're going to do the monitoring setup, the support. So that was kind of challenging too. Who takes ownership? Those were kind of the challenges because we upfront did think about, okay, let's do this error handling and notification, and then later look at what the kind of supported, but I kind of struggled a little bit about who owns eventually the platform and who's responsible for what, taking up what kind of error, etc. The other interesting challenge could also be the connectivity with on-premise network. So we're using the on-premise data gateway, but then again, you have to think about your retrying mechanism when a network fails. within your Logic app. Try to deliver it. If it fails, try it again. You can potentially use exponential backoff in your Logic app. Performance was an issue more or less if you had too many files on-prem. So that's where more the performance came in, or let's say throughput, or is when you can get throttling because you end up getting into the limitations of your file adapters. You have to be wary about that a little bit. The other challenge a little bit was the mapping between a business event, at least the complete, let's say, enriched message toward a production order that had to be sent on-prem, because that was just a limited set of data versus a bulk amount of data you're getting through calling back to Dynamics. The other interesting thing was your business events configuration, which I showed you. If you did a database refresh, basically your configuration was gone as well. So you reconfigure your environments again. So that can be a little bit of a hassle as well. Also, because you're using an app registration, you have to think about the lifetime of that app registration, which is about 2 years, and depending how you configure that. So you have to think about that too. The other thing is your deployments also in consideration or in concert with your change management. Also, when I'm going to push certain Logic apps for UAT testing. So that's an interesting thing too, and it comes back to your ownership. The other thing is with manufacturing, at least some of these processes going on, they can change a little bit. So sometimes that also means that Logic app had to change. So you have to think about branching strategy going forward when you're deploying certain capabilities or a certain Logic app or certain orchestration capability for your business process. And the other thing is a challenge was message sizes, which I have an example of. And this had more to do with your purchase orders, because they can become as large as bigger than your Logic app, or at least your message queue can handle. The standard can handle about 265 in size. And if it became bigger, then we entered into a problem. You could solve this by saying, okay, we'll go into a bigger SKU, but that was kind of costly. So we thought about, why don't we just solve this by using a claim check pattern and get it from a storage account back into another Logic app, because the size itself was not a problem for the Logic app, but it was for your message queue. So this kind of depicts, our message and size challenge. So it's the way I analyze it, and then we resolved it using that claim check pattern. The other thing is, like I said before, with how do we set up the support, how we're going to do, who takes ownership of what. The incident ultimately through an email came in top desk. So that's an email integration in this incident management system. And then, of course, you think about, okay, who's going to do triage? Who's going to, if it's technical or data related. So you see this a picture, there's some Dutch words in there, but it's triage, data related, technical, and who fix it. First, second, and third line support. So where are we going to take? So if it's the customer doing first and second line support, or third tier, you would say, first and second tier, or is it, a company that would basically us doing this, we as an ISV, or is it, only the third tier support that we're going to do in combination with a fourth tier when you're going back to Microsoft if there are any issues regarding the technical setup of the platform. So we're running maybe in some type of issue, or maybe it's a Dynamics type of issue, and then you might have also put in an incident or a ticket with Microsoft saying, hey, there's something within Dynamics that doesn't really function well. So yeah, you really have to think about your support model in general in the complete setup with your interfaces. And then lastly, what's very important as well, going forward, is set up a knowledge base for the DevOps wiki capability. So document your integrations, your flows, your platform, what connectors you're using, what the most common errors could be, what kind of connections you have set up, the complete configuration of your development, test, acceptance, and production environment. And that really is helpful also when it comes down to supporting, that complete setup of interfaces between Dynamics and other systems, and going back to Dynamics again, the holistic view of what I showed earlier. That documentation can really help, and especially if you do it in DevOps, because then you have your knowledge base, your pipeline, your repo, everything centralized within your Azure DevOps, and that really can help going forward once you do your transition to support. So when it comes down to lessons learned, one of the things I already mentioned is that you need to build that knowledge base straight from the get-go once you're setting up your environments and start building your interfaces. Also start documenting this in the DevOps wiki, for instance, or if you GitHub, then you can do that in GitHub. Using that wiki capability was really do that. The other thing I think is, from this going forward, have a sound support system set up. Who takes ownership of what part of the environments, if it's the Azure environment who takes responsibility, when it comes to the Dynamics environment, who's kind of owning that. Those things are important. I think I also made it abundantly clear that logic apps need to be robust. Also, for instance, for monitoring perspective, or at least getting to identify where in my system something goes wrong. So I can identify, okay, this logic app is an issue, and then you try to resolve that. So responsibilities, like I said, ownership is very important also when it comes to supporting in the end. And the other thing, I think the lessons learned, we need a proper change management process overall. So some of the basic things that or at least there could be basic things you think of, but yeah, you have to set this early on. So part of your governance as well. So this is some of the lessons that we learned. So if you want to get in touch, you can do so through LinkedIn. You can visit our website, so that's irc.nl. You can approach me through Twitter. You can look at my InfoQ articles if you like, because I'm also doing some side things like documenting or at least bringing news items out regarding the Azure platform, other platforms, AWS, and so forth. So this is an interesting website too. So that's also a means of getting in touch maybe. And then, yeah, I want to leave you by thank you for attending this and enjoy the rest of the event.